Hi everybody, in this video we're going to learn about quadratic applications. Quadratic applications are problems or situations that can be modeled with a quadratic function, like the situation we're about to read about now. A rocket is fired upward from some initial distance above the ground. Its height in feet, h, above the ground t seconds after it is fired is given by the function h of t is equal to negative 16t squared plus 112t plus 1248. So we have three questions. We're in decimals. We're obviously going to use decimals to solve this. Let's go ahead and start by at least typing in the function, and then we can read over the three questions. Y is equal to negative 16. And listen, I said Y, right? So decimals does not recognize H and T. We're going to have to replace it with Y and X respectively. So negative 16X, and to square it, we come down to our keyboard here. If it's closed, you can open it by opening it up right there. A squared, and that squares your X, plus 112x plus 1248. Okay, so now let's look at these questions. The first question, it says, what is the rocket's maximum height? So in order to find the rockets, first of all, when you think maximum, I want you to think vertex. When we learned key features last week, we learned that the vertex is the maximum or the minimum value of a quadratic function. So in this problem, when they ask us for the maximum height, they're definitely asking us for the vertex. Remember, the vertex is a point. It has an x coordinate and a y coordinate. We have already established that h is going to be y here, and t is going to be x. So now we have to determine which feature of the x of the vertex is this problem actually asking me for. Is it asking me for the x coordinate, or is it asking me for the y coordinate? So the problem says, what is the rocket's maximum height? That's referring to the y coordinate. So once I find the vertex to this equation, I am going to look for the y coordinate to be the answer here. Now, the next part of the question says, how long does it take for the rocket to reach its maximum height? How long? That refers to time. We know that for our problem, we've already replaced t with x. That means the x coordinate of the vertex, because it's at the maximum height, is going to be the answer for this particular problem. So the y coordinate describes the maximum height. The x coordinate describes when it reaches its maximum height. After it is launched, the third question, after it is launched, the rocket reaches the ground at t equals blank seconds. Ground. So if you can imagine, our rocket is going up in the air and it's coming back down and hitting the ground. On the ground, our height is equal to 0. So we want to know, when is y going to be equal to 0? What key feature is when y is equal to 0? That's the x-intercept. So when you think ground, I want you to think x-intercept, because that's when y is equal to 0. So ground is x-intercept. Maximum is vertex. Ground is x-intercept. Now let's get into solving these problems. If you look here, when I graph the function, I can only see the left side of the parabola. I say it's the left side because this value here, the x coordinate, is negative. Remember, we just said x stood for time, seconds. Is it possible to have negative 6 seconds? No. So that means that it has to be a positive value in this problem. And that means I need to increase my domain, my visible domain, to be able to show me what my positive values might be. Here you can see my domain, my visible domain is negative 10 to 10. So I'm going to increase it by 10 to 20 to see if that will allow me to see the width of the parabola. And voila, I can now see the width of the parabola. But what I can't see is the height of the parabola. I cannot see when it's going to reach its maximum height, the vertex. So now I need to adjust my window again, my visible window, to see the height of the parabola. So the way I make my decisions is by looking at my function. Here's my function in standard form. I know that the last term in the function is called a constant term. It's also called the y-intercept. This is where the graph is equal to, the x-coordinate is equal to 0. Okay, so this is the initial height, right? That's the y-intercept. So if you look at my graph, I'm at 5. My y-intercept is 1,248. I am so far away from 1,248. So I need to adjust my window to accommodate my 1,248 y-intercept. Here I see that my range goes from negative 8.5 to positive 8.5. So I'm going to change it to a number that's bigger than 1,248. I'm going to change it to 1,500. And wow, I picked the right number the first time. Okay, so I could stop right there and go ahead. And what I love about Desmos is that when you find that, when you finally get your picture here, you can always just click on the graph to find that vertex. So let me explain what that vertex means. It means at 3.5 seconds, the rocket is 1,444 feet off the ground. At 3.5 seconds, the rocket is 1,444 feet off the ground. So let's go ahead and write that in. So now we're ready to look at the third part of the question. It says, after it is fired, the rocket reaches the ground at t equals 0 seconds. So when I adjust my graph to accommodate, let's move the graph so that we can see where it's going to hit the ground. So we already determined that the ground is the x-intercept, right? So the beautiful part about Desmos is that if I touch the x-axis, right, where the graph crosses the x-axis, I can see my x-intercepts. And so I have one x-intercept at -6 and another one at 13. The only one that makes sense is the one at 13. So our rocket will hit the ground at 13 seconds. So our rocket reached a maximum height of 1,444 feet at 3.5 seconds. And after it is fired, the rocket reaches the ground at t equals 13 seconds. And that's how we solve those problems. Please reach out if you have any questions. Onward to the next example. We have a similar problem here where NASA launches a rocket at t equals 0 seconds. Its height in meters above sea level in terms of time is given by h equals negative 4.9 t squared plus 151 t plus 318. Here we have two questions. How high is the rocket after 6 seconds? How high was the rocket when it was initially launched? So let's go ahead and first get started by graphing our equation. Again, Desmos does not recognize h and t, so we're going to replace it with y and x respectively. So y is equal to negative 4.9 x, and let's square it. Don't forget to square it. Plus 151 x plus 318. All right, so just like the previous example, I can only see my negative answer. That negative answer doesn't make a whole lot of sense. So I need to adjust my window so that I can see my domain to increase, so I can see more positive values for my domain. So I'm gonna go ahead and adjust it to about 50. And now I can see the width of my parabola. All right, but I want to be able to see the height of my parabola as well. When I look at my function in standard form, my y-intercept, which is 318, is the constant term, the last value. That's when x is going to actually be equal to 0, or my initial height. So if you look at my graph, I'm at 4, and that's 318. Yeah, I need to get closer to 318. So I'm going to change my y values to a number that's bigger than 318. So let's go ahead with 500. So that helps. I can definitely see where it's crossing the y-axis, okay? But I cannot see the height. Therefore, I need to change my window again. So I'm going to change it to, say, 1,500. And that's pretty good. Let's go ahead and increase that to about 1,700. And now we can see the top of the parabola, the vertex of the parabola pretty well. Now let's go ahead and answer the question. So I'm going to move this over so I can answer the question. It says, how high is the rocket after 6 seconds? So 6 seconds, there's a couple of different ways I could find this answer, right? I can come down to my x-axis, okay? And I see I'm between 0 and 10 here. And so 6 seconds is going to be 2, 4, so that means it's 5, right? 2, 4, 6. So 6 is here. And if I travel up along 6 and go to the function at that value at 6, okay, it will give me my answer for 6. Now you see how it's like going decimal, decimal. It's not perfect. Oh, I got it. It's perfect. Now, sometimes, you don't have time to play around with that. So, but our answer is 1,447.6. Let's go ahead and figure out another surefire way to find that answer. So you can also take the function here and plug in the value 6 for x because it said at 6 seconds. So 6 seconds means everywhere I see an x, I'm going to replace it with number 6. And so there we go. The answer is 1,047.6 meters. Now, we can also find the answer by looking at the table. So you can take this function here, okay? And I'm going to leave that function there, and I'm going to go ahead and use this one to create the table. Go ahead and click on the gear, and that's going to allow us to turn this function into a table. So I click table, and there goes our table. And so I want to know at 6 seconds, what is our time? So you can type in the number 6, type in the number 6, and it will give us the height the rocket was off the ground, which is 1,047.6. So we've answered the question. All right, now the second part of the question says, how high was the rocket when it was initially launched? Initial launch means at 0 seconds. Well, if you look at our table, at 0 seconds, it was 318. 318 is the same number at the end of the function here, which we already knew was our y-intercept. Our y-intercept is the initial height of the initial launch, rather. So now let's go one more step and show you how to solve this algebraically. If I want to know what the initial height is, I simply let x equal 0. So I copied the function, and everywhere I saw an x, I'm going to turn it into a 0, and voila, there goes our answer, 318 meters. So our rocket, after 6 seconds, is 1,047.6 meters off the ground. And how high was the rocket when it was initially launched? It was 318 meters off the ground.